Hello students, in last lecture we have studied basics in inheritance and variation. Today we have to study the first and most important cross or the experiment carried out by Mendel, and that is monohybrid cross. We have to study what is meant by monohybrid cross, how this cross is carried out, and the conclusions derived by Mendel from this monohybrid cross. The cross between two homozygous parents by considering single character is called monohybrid cross. A cross between two homozygous parents by considering single character is called monohybrid cross, or it is also defined as a cross between two homozygous parents by considering single pair of contrasting traits. By considering single pair of contrasting traits. Okay, single character or single pair of contrasting traits. Now the example, Mendel carried out this experiment or this cross by using two plants, two homozygous parents, which can be represented as follows, like this: parents, or we can write phenotype here. One parent is with tallness, that is tall plant, crossed with dwarf plant. Okay. Single character. Which character? Height of the stem. Okay. Tall plant crossed with dwarf plant. Now what is the genotype of these plants? Now these plants are homozygous plants, and we know about what is homozygous. Homozygous means character. Now this tallness is represented by capital T, small t. These two plants forms gametes. These gametes are haploid, and each gamete receives single allele for a particular character. Genotype can be represented as here capital T and here small t. Now when there is crossing in between these two plants, then there is formation of F1 generation or first filial generation. F1 generation or first filial generation. And this first filial generation is like this. Okay. In F1 generation, the plants produced are hybrid, and these are tall plants. These are hybrid tall plants. Now such a cross is the cross between two homozygous parents by considering single pair of contrasting traits is termed as monohybrid cross. Now in next step, Mendel carried out selfing of hybrid individuals. Now we have to study this selfing like this. Selfing that is F1 crossed with F1, or it is also termed as inbreeding. What is the phenotype of these plants or parents? Phenotype is F1 is tall, here F1 is tall. Okay. Now the genotype. What is genotype of F1 individuals? It is heterozygous condition. It is capital T, small t. Similarly, capital T, small t. Now the gametes. These heterozygous parents forms two types of gametes. That is here capital T, small t. Similarly, capital T, small t. Okay. Now, the cross between these two parents can be represented by Punnett square method or checkerboard. Okay. Now, this checkerboard can be represented as follows, like this. Here, male gametes, female gametes, male gametes, capital T, small t, female gametes, capital T, small t. Now the combination of these gametes, here capital T, capital T, capital T, small t, capital T, small t, and small t, small t. Okay. It is the genotype of these offsprings. Now the phenotype, these are tall plants, these are also tall plants, then they are also tall, these individuals are tall. Okay. Such a representation is termed as Punnett square method or checkerboard method. Now from this cross, we have to identify the ratios, phenotypic ratio, and genotypic ratio. Phenotypic ratio, the ratio of an individuals obtained in any cross on the basis of phenotype. Here phenotypic ratio is 3:1, that is tall as to dog. 3 tall plants and 1 dog plant. Genotypic ratio, it is 1:2:1. That is 1 homozygous tall as to 2 heterozygous tall and 1 homozygous dog. This ratio is termed as genotypic ratio and it is phenotypic ratio. Okay. It is the first cross carried out by Mendel, that is monohybrid cross, a cross between two homozygous parents by considering single pair of contrasting traits in which Mendel crossed two homozygous parents. One is tall and another is dog. When these two plants are crossed in F1 generation, there is formation of all tall plants. But these tall plants are hybrid. In next step, Mendel carried out selfing of F1 individuals, that is tall plants crossed with tall plants. Heterozygous tall plants crossed with heterozygous tall plants. And he obtained the plants in this cross in this ratio, that is 3:1 and 1:2, 2:1. From this cross, Mendel concluded one principle, and that principle is termed as law of dominance. Mendel proposed various principles, conclusions on the basis of the various crosses carried out in the plant. The first law or the first conclusion given by Mendel is the law of dominance. Law of dominance. This statement. This law of dominance states that when two homozygous parents, with one or more pair of contrasting traits are crossed, then the character which appears in F1 generation is called dominant, while the character which do not appear in F1 is called recessive. It is the statement of law of dominance. Two homozygous parents with one or more pair of contrasting traits are crossed, then the character which appears in F1 generation is called dominant, while the character which do not appear or express in F1 generation is called recessive. Similarly, it is also defined as allele. The allele which express its trait in F1 is dominant, while the allele which gets suppressed in F1 generation is called recessive. We have studied monohybrid cross, tall plants crossed with dwarf plants. In F1 generation, all the individuals are tall. That is, the tallness is the dominant character, while the darkness is the recessive character. Okay, it is the first conclusion derived from monohybrid cross. That is the law of dominance. The another law from this cross is law of segregation. Second law is law of segregation. Law of segregation. Now this law states that when two alleles form a contrasting character brought in F1, then they remain together without mixing or altering each other, but they get separated at the time of gamete formation. Okay. Law of segregation. What is law of segregation? When two alleles form a contrasting character brought in F1, they remain together without mixing or altering each other, but they get separate or segregate at the time of gamete formation. Okay. In Mendelian cross, example, tall pea plants crossed with dwarf pea plants, like this. Tall plant crossed with dwarf pea plant, which is represented by capital T, small t. In F1 generation, there is formation of monohybrid individuals, that is capital T, small t. This F1 individual forms two types of gametes, like this, capital T and small t. These alleles for tallness and dwarfness remain together in F1 individual, in F1 hybrid. They do not alter each other, they do not mix with each other, but they get separate or segregate at the time of gamete formation. Okay. Two alleles for a contrasting character brought in F1, they remain together without mixing or altering each other, but they get separate or segregate at the time of gamete formation. Okay. Now these separated gametes, these separated alleles can be get together in F2 generation, and there is a reappearance of dwarfness, and reappearance of dwarfness clears the law of segregation. Okay. Now during gamete formation, each gamete receives single allele for a contrasting character. Okay. Single allele for a contrasting character, and hence this law of segregation is also termed as law of purity of gametes. Law of purity of gametes. In board examination, there is one question. Question is, give a reason. Law of purity of gametes is also termed as law of segregation. Now, why it is termed as law of purity of gametes? Because the gamete receives only single allele, only one allele for a contrasting trait, and this gamete is pure. Gamete is pure for that character, and hence it is termed as law of purity of gametes. And last point about the law of purity of gametes or law of segregation is this law is universal. Law of segregation is universal. Now, why universal? Because all sexually reproducing organisms are always diploid. All sexually reproducing organisms are diploid and they forms haploid gametes. Gametes are always haploid, and hence this law of segregation is universal. Okay, today we have studied monohybrid cross, then the phenotypic ratio of monohybrid cross, genotypic ratio of monohybrid cross, and law of dominance and law of segregation. In next lecture, we have to study dihybrid cross and the one law derived from the dihybrid cross. Thank you.